Hello, I'm Kai Mitchell. My student ID is 12160908, and this is my assignment 2 solution for the Tinkercad simulation. First, we have a 9-volt power supply, then we have a buzzer, a microcontroller, a potentiometer, a DC motor connected on a breadboard. These components are connected to an Arduino Uno R3. These connections can be seen in this table here. Then going to our code, I defined the pins here, and then set up the pins. Then there's a function to configure the timer for fast PWM on PD6. So first we set it to fast, set it to non-inverting, set a prescaler to 64, giving us a PWM frequency of 976.5 Hertz. Then we do a setup function for UStart, universal synchronous asynchronous receiver transmitter for serial communication. This is based on the week 5 lecture code. We enable it, then we set the data format to asynchronous, 8 data bits, no priority, 1 stop bit. Then we set the baud rate to 9600, assuming a 16 MHz clock. Set the upper byte of UBR to 0, set the lower byte of UBR to 103. Then this function here is to receive a character over UStart. So it waits for a flag to occur, waits for the incoming data, then we return the received character from the UStart data registry. This function here transmits a character over UStart, so we wait until a UStart data entry register empty flag is set, wait for it to buffer, then we send the character by writing to the UStart data registry. So here is a function to send a string over UStart. It converts the string into an array of characters and sends one character at a time. So we have the startup or buzzer indicator. So it enables the buzzer for 2 seconds, then turns it off. And this is the setup function for ADC. It sets AVCC as the voltage reference and selects ADC2. It enables ADC and sets the prescaler to 128, giving us a frequency of 125 kilohertz. This function here performs a single ADC conversion and returns the result from 0 to 1023. Starts the conversions, waits for the conversion to complete, and returns a 10-bit result from the ADC register. Moving on to our main function. So it first goes through a bunch of setup methods. This method here is only used for the simulation, won't be used in the physical circuit. We set up the digital pins, set up the PWM timer, set up UStart, and set up ADC. Then we initialize some main variables. This is the ADC value as a string, the voltage as a string, a serial message, the ADC value received from the potentiometer, the voltage received from the potentiometer, the ADC value received from scaled for the PWM. Then here's our startup loop. We first check for the initial K in capitals. Then once that has been entered in, it sends a welcome message, motor controller by Kai Mitchell, my student identifier. It then turns on the buzzer for 2 seconds, then turns it off, then it breaks and narrates to the next loop, so it doesn't keep looping through here. It then sets the motor direction to forward. Then we start in the main loop, which is the ADC reading and PWM control. It reads the ADC value, converts it to a string, and then this calculates the value based on the ADC value. This converts that voltage to a string to be later to be printed down here. We get the PWM value, by scaling the ADC value. Then we set the OCR 0A to update the PDM duty cycle. Then we format this message here, ADC percent voltage percent. So it gives us the message for the ADC value and voltage value, and then it sends it over UStart, and then there's just a delay between readings. So if I start it, if I enter any other character, it's not going to work until I enter K as a capital. If I enter K as a lowercase, doesn't work. Enter K as a capital, it starts, it beeps for a bit, then you can see that the motor is spinning. At the moment we have set the potentiometer to max. We send it to about half, it ends up showing a 2.5 voltage and it goes down half the RPM. Set it to 0 RPM. Set it max again, it becomes 243 RPM, and the voltage in the serial monitor is showing 5, ADC value 1023. As you can see, the RPM scales based on the voltage, and that is my solution. Thank you.